Hey there, welcome back. So today we're going to talk about a better way to find matches. The way that we've been finding matches before is every one of these dots is looking around at every single frame for a match, which can end up having our game, which is pretty simple, act as if it's pretty slow. So you can see right now I've got some slowdown, partly because I'm recording this, but also just because it's a lot of kind of wear on the process as we're going through this if we're looking for matches every single frame when we don't need to. See right there, I had an error where it counted 2 as a match, and I had 3 over here. If you were kind of eagle-eyed last time, I had a script over here that you guys didn't have yet, and I also had an object up here that you guys didn't have yet. That's because I worked ahead and then forgot that I worked ahead and forgot to cover my tracks. So it kind of spoiled what we're going to be doing today. So first thing we want to do is I'm going to create a new game object specifically to find matches. So I'm going to go over here to my hierarchy. I can either hit create and choose create empty. I can right click in the hierarchy and create an empty, or I can go up to game object and choose create empty. This is just going to be just an empty object that's going to keep our match finding algorithm. So I'm going to call this match finder. And then I'm also going to give it something I can see it in the scene. So I'm just going to go over here, select an icon. If you select one of these top ones, these kind of oval looking ones, it'll allow you to read the text. If you select one of the dots, it just appears as a dot. Okay. To go with this new object, I'm going to create a new script. So down here in my scripts folder, I'm going to right click, choose create, C# script, and I'm going to call this find matches. And then I'm going to open up that script. Okay, so in our find matches script, we're going to be doing a couple things. We're going to copy most of the logic directly from the dot class. However, since we're going to be accessing the dots, we're going to need to have access to the board class, which is where we're saving the two-dimensional array that has all of our dots in it. So the first thing I'm going to do in here, make this just a little bit, oh no, it's as big as it goes. First thing I'm going to do in here is I'm going to create a reference to the board class. So I'm going to make this private because I don't need it to be public. I'll do board, and we'll just call it board. And then I'm going to complete that reference down here in the start method. So board is equal to find object of type. And I can use that to do it because there's only ever going to be one board class in the scene. Okay. So the next thing I can do down here is I want to create a list of game objects, and the purpose of this list is to detect when we have a match, if it's a match 3, a match 4, or a match 5, and that's going to come in handy later on when we do power-ups. So what I'm going to do here is create a public, and I'm making it public mainly for debug purposes, just to make sure it works. And this is going to be a public list of type game object, and I'm going to call it current matches. Did I do that wrong? Is it the other way around? Is it game object then list? Geez, I've forgotten how to make a list. 1 second here. Okay, so I have to do public list of type game object, not game state, game object, and this is going to be equal to a new list of type game object. Should like that better. Oh, I have to give it a name. Current matches. Okay, there we go. So what this is doing, a list is kind of similar to an array, although it's easier to add and subtract things to a list than it is from an array. So we're going to create a list of game objects. It's our current matches, and this is going to be just a new list of game objects. So essentially, we're creating a container, and then this new list of game objects is filling that container up right away, so that we have it kind of already initialized. Okay, cool. So the next thing I want to do, I don't need my update method, so I'm just going to delete it. If you don't need your update method, you can always delete it, because even if there's nothing inside of it, it's pulling some system resources. So it's always a good idea when you're optimizing your project to go back through and delete any empty update methods, just to save yourself a little bit of energy. All right, so I'm going to be using pretty much the same logic that I had in my dot when I was finding the matches. And if you don't remember, in the dot, what we did is we took each dot and we looked left and right. And then if those left and right were the same as, they had the same tag as ours, then we set everything to be as matched. So in here, I'm going to do something similar. I'm going to make a private, and this is going to be a coroutine, so I'm going to call it an I enumerator. And this is going to be find all matches co. And enumerators, I enumerators become red right away if you don't have a return statement somewhere in there. So I'm just going to build in a little pause right here. So yield, return new, wait for seconds, and I'm going to have it wait 1/5 of a second. Okay. So now, again, this should be pretty familiar to you guys by now. I'm going to have a double for loop here so that I can look through all the pieces on the board. So for I is 0, I is less than board dot width, I plus plus, and then for j is, oops, I keep doing that, int j is 0, j is less than board dot height, j plus plus. Now what I want to do is I want to set a current dot to whichever dot is in the ij position. So I'm going to say game object current dot is equal to board dot all dots ij. Sorry about that weird cut there. So I'm doing game object current dot is equal to board dot all dots ij. So I'm looking for a current dot that we have. And first I want to make sure that this current dot isn't empty, which could happen sometimes if it starts checking like right when we destroy a dot. So I want to say if current dot is not null, so that I don't get any weird null reference exception errors. And then I want to say if I is greater than 0, meaning if we're in at least the second column, and I is less than board dot width minus 1, meaning if we're in at least this, or if we're in no more than the second to last column. Then I want to set up the left dot and the right dot. So I'm going to do game object left dot is equal to board dot all dots I minus 1j. So the dot that's directly to our left. And then game object right dot is board dot all dots I plus 1j. Okay. And now I want to check to see if either of those are null, meaning if they were just destroyed. So if left dot is not null and right dot is not null, then I want to do some stuff. So if neither of them are null, then I'm going to check to see if their tags are the same as the current dot's tag. So if left dot dot tag is equal to current dot dot tag, and right dot dot tag is equal to current dot dot tag. So we've got quite a few nested if statements here. First, we want to make sure that the dot that we're currently looking at exists. Then we're going to check to see where its position on the board is, meaning if I is greater than 0 and less than board width minus 1, meaning the last column the second to last column or less. Then we're creating two game objects, and we're checking to see if those exist. And then if they exist, then we're going to check their tags. And if their tags are equal to ours, and all of these if conditions are met, then what we want to do is say left dot dot get component, And the component we want to get is the dot script. Dot is matched is true. And I'm going to copy this line a few times. So I'm going to copy that. And I'm going to do it here for right dot and current dot. So I'm going to do the same thing for right dot and current dot. Okay, so I'm going to set all of them to be true. Cool. Now, I'm going to do some similar logic with the up and down matches, because this is just horizontal. So I'm going to copy all of this and paste it right there. So this is still inside the double for loops and still inside if the current dot isn't null. So inside if current dot isn't null, we're checking to see the column position. And now right next to that, we're going to check to see the row position. So if j is greater than 0 and j is less than board dot height, so I'm going to change this to a j. Okay, and then instead of being left dot, this is going to be up dot. And instead of being the one to our left, it's going to be I, j plus 1. And then this is going to be down dot. And down dot is going to be I, j minus 1. J minus 1. Okay, I'm just going to copy up dot here. And everywhere I saw left dot, I'm going to paste that. And left dot right here. I'm going to copy down dot. And, oops. I'm going to copy this and not paste it. And everywhere I saw right dot, I'm going to paste down dot. Okay. All right. Cool. So there's our coroutine here. Now we're going to have to do something extra for the list, but we'll get to that in just a second. I want to call this coroutine from a separate method. You can't call a coroutine from another script, but you can call a method that calls a coroutine from another script. So this is going to be public void find all matches. And then inside this, I'm just going to start the coroutine. So start coroutine, find all matches co. All right, cool. So now I have my find matches script here. I'm going to go over to my dot object, and right now go up to my update method in my dot object. And currently I'm having it finding matches every frame. I'm going to dash that out. And then instead of finding matches every frame, I want to be finding matches when I'm moving towards my target. So what I'm going to do is I'm going to make a reference to my find matches script. So private find matches. I'll call this find matches. And then in my start method, I'll complete that reference. Find matches equals find object of type. And the object I want to find has a find matches script attached to it. And then in here, I'm going to check when I'm moving towards the target. I'm going to do find matches dot find all matches. And I'm going to copy this line here, and I'm going to paste it in if we're moving vertically. Okay. So that should be fine. Let's save this. Let's go back into Unity and let's check to see what I broke. So this is going to compile for a second. I'm going to go to my match finder object and I'm going to attach my find matches script to it. I have my current matches list here, which I haven't done anything with yet. I'll do something with that in just a minute. So I'm going to hit play and we'll see if I broke anything. So the pieces slide in. Okay, cool. I didn't break anything. Still works. Now this should be a little less memory intensive as far as the system goes, because instead of looking for a match every single frame, we're now looking for a match only when we tell it to, only when we know that something isn't in the right place. This also should fix some of those issues where we were getting match 2s to count as a match 3, There's one specific situation where that happens, and I'm trying to see if I have it on my board right now. So let me see if I can make it happen. It happens when you have two of the same color, and then this and this are also the same color. Or it could happen vertically, where you've got two of the same color, and then here and here are also the same color. Okay, so that still works. I almost have it here. I'm just going to fast forward through this until I find one. Okay, so I've got it now. So I have a situation here where I have these two dots and then that are one color, and then these are also the same color. So before, if I had pulled this one up to switch with the green, it would have registered these three as a match because this one would switch up there. But it also would have registered this and that as a match because it would have registered this temporarily as being in both the position it's currently in and the position it's moving to. So it would have thought that these were three of a match, but there we go. Now it doesn't. So we fixed that logic error that we've had for quite some time now. Okay, cool. So now let's deal with that list. So the reason I wanted, wrong thing. Sorry about that. The reason I wanted to make the list is because I want to know if there's a match 3 or a match 4, and I can do that easily by adding and subtracting to the list when things get matched. But then also, I can check the length of the list, or if things in the list have the same X or Y position. So what I'm going to do here is right before I do my left dot stuff, and this code could desperately be refactored, but for now I'm just going to bear with it. I'm going to say if current matches dot contains, and then I want to do left dot, and I want to do the negation of this, so I'm going to do an exclamation point in front. Then I want to do current matches dot add left dot. Okay, and now I'm going to do the same thing for the right dot and the current dot, and then the up dot and the down dot. So I'm going to copy this code here. And like I said, this can be refactored, and we should probably do that next time. But kind of coming up on time here, so let's do it the lazy way. Okay, so there we go. And now I'm going to do the same thing for current dot. So I'm going to paste here. Oops, not what I meant to do. I'm going to copy all of this again. I'm going to paste here. And instead of being right dot, I'm going to say it's current dot and current dot. All right, so I can copy this whole if statement here and go down here, paste there, and paste there. So I'm going to change this from current dot to up dot. All right, and then copy, paste, and then this is going to be down dot. Copy and paste. And then I got current dot. All right, cool. So I'm going to save this, and I want to show you what happens here. So if we go back to Unity, it's going to compile for a second, see if I meet any errors. Okay, cool. So we got our current matches here. If I hit play, I want you to kind of pay attention to what happens to the current matches over here. So I'm going to make a match right there. And there we go. So we grabbed a bunch of matches, but as soon as they get destroyed, they get said that they're missing. So what I want to do here is go to my board object. So I need to open up that script. And when I destroy the object, or the piece, I want to remove it from that list. So I have to make a reference to the find matches in here. So I'm going to do public, or actually not public, we'll make this private. And I might as well put it next to the other thing that I'm actually, I'll put it down here. So we'll do private find matches find matches, and then I'll complete that reference. Find matches equals find object of type, and the object I want to find is find matches. Okay. And then I want to look at my place where I'm destroying the matches at. So I've got my destroy all dots column row, and then I'm making that all dots null. And I also, before I destroy it, I'm going to remove it from the list. So find matches dot current matches dot remove remove all dots column row. Okay, so this should make it so that we don't have all those weird missing places in our list, so that our list doesn't get unmanageable. So I'm going to save my script, jump back to Unity. I'm going to bring up the match finder again just so I can watch this, and then we'll hit play. Okay, so as this comes up, I want you guys to be watching over here my current matches. So I'm going to make a match, and see it was 3 there for just a tiny second, and that seems like it's nothing, but it's enough for the program to actually do stuff with that. So that way we can later on check to see if we have 4 or 5 things in there, and if we do, we can generate a power-up. So yeah, cool. All right, well, thank you very much for watching. If you have any questions, please feel free to leave them in the comments below, and you can add me on Twitter if you want to know the second I post a new video. Other than that, I hope everybody has a wonderful day wherever you are. Thank you very much.